Today, we're diving into something pretty wild, a hidden pattern that connects, well, almost everything, from a simple coin flip to the heights of millions of people. We're going to look at a completely new explanation for one of the most basic rules in the universe, the Central Limit Theorem, and maybe discover that order comes from chaos in a way you never, ever expected.
All right, so think about this for a second. You've got the results of hundreds of coin flips, or say the heights of everyone in a big city, or even the tiny errors a machine makes over and over again. On their own, they seem totally random, right? Just noise. But here's where it gets kind of magical. When you collect enough of that random data and zoom out, bam! A perfect, predictable shape just appears out of nowhere. And that shape, you've definitely seen it before. It's the famous bell curve. Now, there's a mathematical reason for it, a big one, called the Central Limit Theorem. And for centuries, it's basically told us, hey, if you add up a whole bunch of independent, random stuff, you're probably going to get this shape. It's reliable. It just works.
But okay, that tells us what happens. It doesn't really tell us why, does it? I mean, why that specific shape? Why the bell curve and not, a squiggle or a square? Is it just some weird coincidence of the math, or is it a clue that something else is going on, something much, much deeper?
That exact question is what led one researcher to a pretty radical idea. What if this pattern isn't really about statistics at all? What if the bell curve is actually showing us a fundamental rhythm, like a heartbeat, of reality itself?
This idea is called Triune Harmonic Dynamics, or THD for short. It was proposed by a researcher and author named Kevin L. Brown, and his whole take is that the bell curve isn't just a result on a graph. Nope, he thinks it's a signature, a footprint even, of a universal process of transformation that's happening all the time, all around us.
So what is this process? Well, at the core of THD, there's this simple repeating cycle. You can think of it like a 3-6-9 rhythm. First, you've got emergence, that's number 3. This is where a bunch of new individual things pop into existence. Next comes contrast, number 6. This is the messy part, where all those things get mixed together, they interact, they get put under pressure. And finally, there's integration, number 9. This is where a new, stable order emerges from all that chaos. Something new and whole is created.
Okay, so a 3-6-9 rhythm, emergence, contrast, integration. It might sound a little abstract, right? So how on earth does that connect back to a bell curve in a math textbook? Well, the connection is actually way more direct than you'd think, and it completely changes how you look at the whole thing.
This is the real aha moment. Let's map it out. That first step, the base phase or emergence, in statistics, those are your individual random variables, each separate coin flip, each person's measured height. Then you've got the pressure phase or contrast. What does that look like? It's just adding them all up. When you do that, you're forcing them to interact. Their individual quirks, their sharp edges, they all start to get smoothed out. And finally, integration. After all that pressure and mixing, what do you get? A stable, predictable, large-scale form. And guess what that form is? Yep, the bell curve.
So you can really see the difference in thinking here. The standard way is to just say, well, it's a math theorem. You add things, you get a bell curve. End of story. But the THD view reframes it completely. It says the bell curve is physical evidence. It's the statistical mark left behind when a system of different parts gets squished together and successfully forms something new and whole. It's proof that the 3-6-9 cycle just happened.
Now, this is a really cool idea, but for any idea to be actually scientific, it needs to do one crucial thing. It can't just explain why it works. It has to tell you when it should fail. Yeah, that's right. A good theory makes predictions that you can go out and test. It's got to stick its neck out. That's called falsifiability, and it's what separates a real scientific hypothesis from just a nice story.
And the THD explanation does exactly that. It lays out some very specific rules. It says, look, if you have a system where you've got a ton of contributors and they're mostly doing their own thing, and you don't have any wild, extreme outliers, and no single piece is so big it drowns out all the others, then when you add them up and normalize them, you have to get a bell curve. If those conditions are met and you don't get a bell curve, then boom, the hypothesis is wrong. It's a testable claim.
And this is the flip side, which is just as important. The theory tells us exactly when the magic won't happen. For instance, if all the little pieces are heavily dependent on each other, they're not really random anymore, are they? They'll hold on to their own weird shape. Or what if one contributor is just massive, a giant outlier? Well, it's going to completely dominate the average and you won't get that smooth bell shape. In THD terms, the pressure isn't enough to integrate that big piece.
So the theory itself tells you where its own boundaries are.
So it all boils down to this one powerful idea. The Central Limit Theorem is the statistical signature of structured integration in additive systems. In other words, it's the evidence you see when a bunch of things have successfully come together to build something new and stable.
So what THD really gives us is a whole new lens to see the world through. That bell curve is no longer just some abstract line on a graph. It's a footprint. It's a sign that reality is organizing itself right in front of our eyes. Every time you see one, the theory suggests you're actually watching the end of that fundamental cycle: emergence, a period of contrast and pressure, and then finally, successful integration.
And that just leaves you wondering, doesn't it? The idea behind Triune Harmonic Dynamics is that this 3-6-9 rhythm isn't just for statistics. It's supposedly happening everywhere, in physics, in biology, maybe even in how we think. The bell curve is just one clear echo of it. So it makes you ask, if there really is this hidden rhythm to how order is created, what else are we not hearing? What other kinds of universal music are playing all around us, just waiting for us to figure out how to listen?